All right, we got number 59, which actually is a pretty tricky problem. The problem would be a lot easier if they were to compare like chemical families. Suppose they said which is going to precipitate first, lead chloride, lead bromide, or lead iodide. In other words, suppose they said you had a solution that contained chloride, iodide, and bromide, and they were going to ask you which one of these three substances would precipitate first if you were to add lead to it. Then the problem would actually be pretty easy, because whoever has got the smallest KSP would precipitate first. So the KSPs of these guys are 1.6 times 10 to the negative fifth. Bromide is 4.6 times 10 to the negative sixth. And iodide is 1.4 times 10 to the negative eighth. So if these were all the same, meaning like it's always lead, always bonded to a halogen, and the subscript is the same, then you can just go off of the KSPs, and lead iodide would be the first to precipitate because it has the smallest KSP, then the lead bromide, and then the lead chloride. So if comparing apples to apples, then the smallest KSP precipitates first. But unfortunately for us, in number 59, we are not comparing apples to apples. We are comparing apples to oranges. In our beaker, we have fluoride. We've got sulfide. It's a 2-, and we have phosphate, which is a phosphate, which is a 3-. And we're going to add our lead ions. And we want to know which one will precipitate first. So unfortunately, we're going to have a little bit more work involved. The concentration of the fluoride, the sulfide, and the phosphate are all the same. Okay? That part we know. So the fluoride is 1 times 10 to the negative fourth molar. The sulfide is 1 times 10 to the negative fourth molar. And the phosphate is 1 times 10 to the negative fourth molar. Okay? So our three reactions are going to be see, there are two fluorides in this situation. Our second equation is this. There's only one sulfide there. And then our third equation is and now we have a 3 in front of the lead and a 2 in front of the phosphate. So unfortunately, we cannot compare apples to apples here. We're going to have to work out each one individually and calculate the lead concentration required to cause a precipitate. So we might as well just begin with the first one. So the KSP is going to be equal to the concentration of lead to the concentration of fluoride squared. Okay? So the KSP is 4 times 10 to the negative 8th. That's given in the problem. I don't know the concentration of lead, but they did tell me the concentration of the fluoride. So I solve for X, and it comes out to be 4 molar. So that is the concentration of lead required to cause lead fluoride to precipitate out into a solid. Okay? So let's remember that number and move on to the next one. Lead sulfide. Alright, so my KSP is concentration of lead. Sulfide, we're not raising anything to any power. The KSP for this one is 7 times 10 to the negative 25th. We don't know the concentration of lead, but we do know the concentration of the sulfide ions. Solve for X, and I get 7 times 10 to the negative, whoops, I got the KSP wrong. The KSP is to the 29th. So this comes out to be 10 to the negative 25th molar. So that is the concentration of lead that will cause lead sulfide to precipitate. So this is a much smaller concentration than the 4 molar for the lead fluoride. And now our last one, lead phosphate. Okay, so KSP is equal to the concentration of lead, but this time I'm going to raise it to the 3rd power because there's a 3 there. I'm going to raise my phosphate to a power of 2 because I got a 2 there. And the KSP for this one is 1 times 10 to the negative 54th. Concentration of lead cubed. Concentration of my phosphate. Again, we know the concentration because they gave it to us. So we put it into our calculator, solve for X, and we get 2.2 times 10 to the negative 17th molar. So now we can compare the 3. So we have this concentration. We got this concentration, and we have this concentration. So as it would be, the one with the smallest concentration will precipitate first, and that is the lead sulfide. So lead sulfide will precipitate first at a concentration of 7 times 10 to the negative 25th molar of lead. In second place comes lead phosphate. That is when the lead reaches a concentration of 2.2 times 10 to the negative 17th molar. And in third place comes the lead fluoride. when the lead reaches a whopping concentration of 4 molar, then the lead fluoride will precipitate.